Okay, continuing with the review for section 6.1, the section notes for MAC 1114. We're picking up with example 5. In example 5, you're shown a picture of a circle. You have two rays digging into the circle, creating an arc, but also creating what's called a sector. That would be this portion of the circle that looks like a piece of pie. You have a central angle theta, and you're being asked to find the area, that's what A is, for this entire sector. So the formula they have for you here, it's 1/2 r squared times theta. Again, the theta needs to be in radians, just like in the arc formula, arc length formula. So you're going to make sure that whenever you're working a problem, that if they do give you a theta in degrees, you'll convert it to radians before computing the area of the sector. So in this problem, they've asked you to find the area of the sector. So you're going to be grabbing the formula from above. You're going to put the radius in and square it, and you're going to put the theta also. So the radius will go here, the theta will go here. Don't forget it has to be in radians. And then continue reading the problem to see if they've given you these items. Sometimes they give you the area and then you have to solve for one of these, which is the harder version of this problem. But I believe in this one we have the radius, which is 2 feet. By the way, when you're doing area answers, the units are always two-dimensional, squared. And then we have an angle of 30 degrees, but we can't go and put 30 degrees in there because that is not in radians. So we're going to come off to the side, and first we're going to convert the 30 degrees into pi radians. And you can even put it into the problem in pi form. Rather than, oh, now wait, it says round the answer to 2 decimal places, so you can actually take it all the way to decimal form. If you want to plop it into this formula in pi form and then convert the final answer to decimal form, that'll give you a somewhat more exact answer. But first, converting the 30 degrees, there is 180 degrees in 1 pi radians. The degrees would be gone at this point, and it would be 30 pi over 180. 30 over 180 is 1/6. This reduces, and you can do that in your calculator, reducing that to 1 pi over 6. You can come and put that right in here, and then go ahead and do as much or as little as you need to in the calculator. It's going to be 1/2, that's 0.5. 2 squared is 4, and the units are squared as well as the number. It's 2 squared, which gives you 4. The units are feet squared because you're squaring the units also, times pi over 6, and now go ahead and put that into the calculator. Okay, so entering 0.5 times 4 times second function pi. I'll just show you what I'm entering into my calculator. Divided by 6, and you get 1 point, it says round to 2 decimal places, 1.05. And that's in feet squared, and that is the area of the sector. Moving on to part B, example 5. In example 5, again, it talks about the sector, so the area of a sector. This time they're giving you the area, so we're going to be plugging this 9 pi in for A. Formed by a central angle theta. The theta is in radians, so that's good. We don't have to come off to the side and convert it into radian form because it already is. And we're going to be looking for the radius. So in these problems that involve a formula, you're always going to want to write the formula first. You can write that 1/2 as a 0.5 if you'd like. It's probably the easiest way to enter it into the calculator. They give you, and then start plugging in the things they've given you. They give you 9 pi for the area. They give you nothing for the radius. That's actually what we're solving for. So what is the radius? Find the radius. That's the actual question. And then for theta, it's pi over 2. Okay, so now when you're solving here, you might want to clean up the right-hand side by going 0.5 times pi divided by 2 and just getting yourself like one decimal. I would go out to at least the 4th place with the decimal that you're going to get from your calculator just to keep the final answer a little bit more accurate. So why don't we blend this number and this number. Go 0.5 times pi divided by 2. So now the problem will be, I'll continue it right here, 9 pi on the left-hand side, on the right-hand side. Putting that in your calculator. 0.5 times second function pi divided by 2. You get 0.7854. 0.7854 times r squared. We're trying to solve for r, so first we need to get r squared by itself before we can solve for r to the 1st degree. So just divide off this coefficient, 0.7854. This will cancel, leaving you with r squared. Go and get a decimal for this, 9 pi, 9 times pi, divided by 0.7854. So let's put that in together. 9 times second function pi divided by 0.7854, and I get 35.9999. And then last step, you want to go from r squared to just r, so you want the square to go away, so you need to take the square root of this side as well as this side. Radius is a positive type of number. It stands for length, the length of the radius, so only give the positive root. So finish this problem by doing square root of the 35.999. Now you still have the entire number in your calculator, so at that point you could just go second square root, call up that square root symbol, and you can just copy and paste that entire answer for even better accuracy right into your calculator. So if you want to paste the answer, go second answer. It's where the minus sign is. Close it up and press enter. Excuse me. And the answer comes out 5.9999. And if you want to round it to the 10th place, round it to the 10th place, and let's see, I don't believe there were any units on anything, so that would be the answer. Oh, sorry about my terrible cough. Okay, now we get into speed. And they talk about linear speed. That's when you're moving along a linear path like this. How fast you're moving along a linear path, that would be designated by this little V. And then there's also when you're moving along a curved path, and that would be called angular speed, which we use the letter omega for that. Okay, so 2 different kinds of speed formulas, straight path, curved path, and I'm going to show you how you can relate the 2 formulas. Okay, the S that you see here, don't forget that S stands for arc length, and arc length does have a definition, and that would be r times theta. So you're going to see that when we start to merge these 2 formulas, that when you go to write linear speed, you can replace arc length, S, with its equivalent, which is r times theta. You see that right down here towards the bottom of the page, about 3/4 of the way. So this is the linear speed formula, S over T, which can be related to a circle. So you can go from a linear definition, which is what you're seeing here, and relating it to circle concepts. So in for S, we can put its equivalent. Arc length is equal to r times theta. That's S. These two things are equivalent, so you can substitute this expression for this. And now this formula becomes this. Now when you separate these, if you were to take this r and just pull it off to the side, as you see right here, then you see that part of this newly written linear speed formula is that omega that we talked about, called angular speed. So you are merging this formula with this one so that concepts of linear speed can be related to angular speed. Okay, so here's the omega. Again, r is radius. This is the central angle. T stands for time. So the reason this is called a rate, it's because it's how fast you're moving in an angular sense per, that's this line, unit of time. Okay, let's start to look at the problems that you're being asked to do. In this one, they give you the formula angular speed, omega, is equal to theta over t, and they want you to find the missing values. This is more or less an exercise of, do you know how to manipulate arithmetically? Do you know how to do the correct arithmetic operations? So start again by writing the formula. You're just using the angular speed formula. Remember, theta always has to be in radians in this formula, so luckily in this problem it is, so you don't have to go off to the side and do anything extra. Just in there for theta, your numerator is going to be 3 pi over 4 radians. A pi type number is considered radians. Then unit of time, 7 seconds. So you're moving this many radians every 7 seconds. But you're going to want to convert this into just a complete decimal, because right now it's kind of a mess. You can give the answer in 2 different forms depending on what MyMathLab asks you. If they say, give an exact answer, don't put it in your calculator. I mean, you can let the calculator help you do the arithmetic, but don't press the pi key, because then you're going to go into complete decimal form. So an exact answer would be top divided by bottom. Now when you're doing one fraction that's part of another fraction, what you're going to need to do is know the other way to express division with fractions. Division with fractions can also be written as top, numerator, multiplied by the reciprocal of the bottom. The bottom right presently is 7 over 1. The reciprocal would be 1 over 7. Okay? Multiplication by the reciprocal is the same thing as division. So this is just a way to get an exact answer. So it's top times top, 3 pi, bottom times bottom, 28. So if they ask you for an exact answer, you are moving 3 pi units every 28 seconds. If you want to go further than that, and you want to go into decimal form depending on what you are asked, in MyMathLab, you can do, turn it into a decimal. You can go 3 times pi divided by 28 and give the answer like that. And it would just be that many units per second. So if you do go that far, but this is the exact value. See how they didn't tell you to round anything here? So really you should just give the exact answer whenever it says that. Let's not even go into decimal form here. I want you to get used to when are you allowed to use the calculator. Okay, let's go to the next problem. And in this problem, on the last page, part B, you see a picture of someone who is swinging a rope with a rock at the end in a circular fashion. It says The child is spinning a rock at the end of a 2-foot rope. That rope, being 2 feet, is going to be your radius at a rate of 180 revolutions per minute. So we're going to start this problem with the 180 revolutions per minute. The formula that we're going to be using here is going to be, let's see, what do they want? Find the linear speed. So the linear speed would be arc length per unit of time. But if you want to relate it to the things that you're seeing in this picture, like a radius and a theta, this is the theta. See how he's swinging it in a complete circle? That's the theta. Okay, so this is R times theta over T. And we don't really need this here. Okay, so now what you could do is come over here. Let me slide this over. I'm going to slide the R out and just keep these two as a rate. Going so a certain distance around the circle per unit of time. That can also be looked at as omega. Okay, the radius is the 2 feet. And then you're going to multiply that by the theta over time, but the theta needs to be in radian form. Right now they're giving it to you in revolutions per minute. So you're going to go 180 revolutions per minute. We'll put it over minutes when we go to plug it in here. Okay, then we're going to use our knowledge of the fact that all the way around a circle, so he's rotating this rope, he's swinging the rope 1 full revolution. And 1 full revolution is equal to 360 degrees. 360 degrees is equal to 2 pi. So that's what we want to use when we go to convert the word revolutions. We want to get that word out of there. So in 1 full revolution, 1 swing around the circle is 2 pi. These thetas always have to be in pi form, radian form. So now what you're going to do is go 180 times 2. So you have 360 with a pi hanging off the end. So it's 180 times 2, 360 with the pi. The word revolutions are gone. You are now in pi form, which means you're in radian form. So you're prepared to finish this problem. So you're going to come over here, and you're going this far per minute. 1 full revolution. He's going, 1 full revolution is 2 pi, so he's moving at a rate of 180 revolutions per minute, which is what it says right here in the problem, or 360 pi. That's the 180 revolutions per minute. And then you continue the problem going 2 times 360, which is 720 pi. Per minute. Now let's get a unit on the top. When we were multiplying here with the 2, see how there was feet as part of the radius? So that, and the feet's at the top because 2 is the same thing as 2 over 1. So that unit belongs at the top. Now you could go further with this, or You can give it in decimal form. What I would like you to be able to do is sometimes in my math lab, you will get your answers in certain units. Like this answer is in feet per minute. That's the linear speed. So you've done the answer, but then the next part they might ask you something like this. What is the answer? Because they want to see if you can convert from unit to unit. What is the answer in miles per hour? So you really are already done with the trig concepts when you get the answer of 725 feet per minute. You have done the linear speed, but then this would be more of a practice in getting your answer into different units. So at that point, you would take what you already have, 720 pi. This is an exact answer you have here. We didn't go to decimal form. That's because it didn't say round to anything. Feet per minute. And we're going to try and drag these units into the problem. So first thing, you can either get rid of the feet first or you can get rid of the minutes first. It just doesn't really matter, but you do need to get rid of both of them. So, and you can do it as one continuous problem. You need to be able to convert it here. So I am going to go after the feet and trying to bring it into miles. Okay, so if I want feet to go away, I need feet in the top and also in the bottom so that they'll cancel. The equivalency from feet to miles is there are 5,280 feet in 1 mile. That gets you that drags miles into the problem. Feet would be gone at that point. So you got the miles. Now you want to get hours. So you want to get rid of minutes. So if minutes is at the bottom and you want it to go away so that you have a new unit of time, put minutes at the top. You have to have the same unit top and bottom if you want that unit to go away. So there are 60 minutes in 1 hour. This drags hours into the problem. Like I said, you did have the answer here, but they oftentimes will ask you to get it into a different unit by the end of the problem and make you give 2 different answers. Okay, so now you have everything in here. The minutes are gone now. Now you have miles at the top, hours on the bottom, just as this is asking right here. And now you can put the whole thing in your calculator. Why don't we give a decimal answer this time? So it's going to be, just so you have practice in both, even though they really didn't ask you to give a decimal answer here. But, you know, if they asked you for something like this, they might allow that, a decimal answer. So it's 720 times pi times 60 divided by 5280. So 720 times second function pi times 60. Those were all the numbers at the top, and then the only divisor that means anything was the 5,280, and you get 25. Let's round it to the tenths place. 0.7. The units are now miles per hour. You just slide the units off to the side. Okay, so I gave the answer 2 different ways. I gave it in miles per hour and originally in feet per minute. Okay, so this is one answer. This is the same answer but in different units. Okay, last question for the section 6.1 outline problems. Okay, so just reviewing, this outline has reviewed all the concepts in section 6.1. Remember, there's additional examples in My Math Lab, and you can use these videos to help you get through the My Math Lab. Okay, in this one, we have a 70 horsepower outboard motor. That doesn't mean anything with respect to the calculations you're going to do. That's just the type of boat it is. Rotates its propeller. Now here comes the information that you need. Rotates at a rate. So this is the theta over time of 6,200 revolutions per minute. So same thing as this problem here. Find the angular speed of the propeller in radians per second. Okay, so let's go grab the formula for angular speed. Angular speed, that's the Greek symbol, omega, and it is theta, which has to be in radians, per unit of time. Okay, so in this problem, you're first going to take the rate at which the propeller is moving. They want it eventually in radians per second. Right now it's in revolutions per minute. Okay, so what you're seeing right here is the theta over time. It's 6,200 revs per minute. That's every 1 minute. You don't have to put the 1 there. I do not want the word revolutions in there. I want the theta to be in pi. So when you go 1 full revolution around a circle, 1 full rotation around a circle, you have traveled 2 pi radians. Also 360 degrees, but we don't use degrees in these type of problems. The word revolutions would be gone, and you'd now be at 12,400 with the pi there. Per minute. You can put the 1 there if you want. So you still have your omega and your time every 1 minute. And they've asked you, so what you've really done is you've gotten the answer right here. This is the omega. It's just that it's not in radians per second. It's in radians per minute. This is radians up here. Anything in pi form is radians per minute. So now what you want to do is continue with this problem but get it into seconds. So it's 12,400 radians per minute. We're going to get rid of the minutes and we want it radians per second. We want seconds down here. So for every 1 minute there are 60 seconds. You can use the symbol for minute and seconds if you don't want to write it out like that. Minutes is gone. So now it's 1,000 or 12,400 divided by 60, but now you'd be in radians per second, which is what they asked you to do right there. Just get that in your calculator. So 12,400 times second function pi divided by 60. If you want to give a decimal answer. If you want to give the exact answer, and this doesn't say to round it, but this would be, the exact answer would be where you just reduce this. You would just go 12400 divided by 60. So this would be the answer in exact form. You would just you would just be reducing it. You would be reducing 12,400 divided by 60, so 620 over 3. The pi would just be there. Okay, that's the exact answer. Let's practice getting it rounded to the tenths place. So you would go 620 times pi divided by 3, and the answer at that point would be 649.3 radians. Radians means either pi form or decimal form per second. Okay, exact. And this is an when you round off, it's approximate. Okay, that concludes all the examples for section 6.1.